What you're looking at here is the Crab Nebula, also known as Messier 1, captured with a 5-minute exposure on my Seestar S50 smart telescope. Although it appears faint and delicate, this object represents one of the most violent events in the universe. This light comes from debris from a massive star that exploded nearly 1,000 years ago. The image demonstrates that even modest equipment can reveal genuine astrophysical processes at work. In this video, I'll use my image as a starting point to expose what the Crab Nebula is, how it continues to emit energy today, and what physics lies behind the faint glow. To find the Crab Nebula, look through your telescope near the star Zeta Tauri in the constellation Taurus. Through a small telescope, N1 appears as a faint, fuzzy patch. The Crab Nebula is classified as a supernova remnant, meaning it is the aftermath of a stellar explosion rather than a star-forming region. When a massive star reaches the end of its life, nuclear fusion in its core can no longer support the star against gravity. The core collapses rapidly, while the outer layers are blasted outward in a powerful explosion. What we see today is the exploding debris from the explosion. Gas, dust, and high-energy particles racing outward into the stellar space. Every filament in the image traces material that was once part of the original star. Unlike most astronomical objects, the origin of the Crab Nebula was directly observed by humans. In the year 1054, Chinese astronomers recorded a new point of light in the sky, which they called a guest star. Historical records describe it as being very bright enough to see during daylight and visible at night for several weeks. By measuring how fast the nebula is expanding today and tracing that motion backwards, astronomers have confirmed that this expanding cloud originated exactly the same time as those historical observations. The light from the Crab Nebula does not come from reflected sunlight or nearby stars. Instead, the nebula is glowing because energy is being supplied internally. High-energy particles move through the gas, colliding with atoms and exciting them. When these excited atoms return to lower energy states, they emit light at specific wavelengths. This process explains why nebula continues to shine centuries after the original explosion, long after any initial flash of light has faded. At the center of the Crab Nebula lies a neutron star, the collapsed core of the original massive star. A neutron star is incredibly dense, packing more mass than the Sun into a sphere roughly the size of a city. It also rotates extremely rapidly, about 30 times per second, and possesses an intense magnetic field. This object acts as a cosmic engine, continuously injecting energy into the surrounding nebula and driving much of the radiation we observe today. Within the Crab Nebula, charged particles spiral through strong magnetic fields at enormous speeds. As these particles accelerate, they emit radiation across the electromagnetic spectrum, including visible light. The filaments and wisps seen in images trace the paths of those particles and the structure of the magnetic fields. This makes the Crab Nebula a natural laboratory for studying extreme physics that cannot be reproduced on Earth. Despite the tremendous energy involved, the Crab Nebula appears faint when viewed through a small telescope. The nebula lies more than 6,000 light-years from Earth, and its light is spread across a large region of space, reducing its brightness per unit area. Capturing this image means detecting individual photons that have traveled for thousands of years before finally reaching our telescope. My image of the Crab Nebula is not just a photograph of a distant object. It's evidence of a fundamental physical process operating over long periods of time. It represents the death of a massive star, the conservation and transfer of energy, and the continued influence of that energy on surrounding matter. With a modest telescope and careful observations, we can directly observe the long-term consequences of stellar explosion that occurred nearly 1,000 years ago. Thank you for watching.